Hey guys, so today we had learned about the percent composition and how you find that by doing the percent by mass for every element. Then I had you guys copy down some notes right here for steps on doing the opposite. You take the percent composition for each element given in a formula, and then you have to determine what the formula is. So we learned what the empirical formula is. It's the simplest whole number ratio of subscripts, okay? And we're going to follow these steps to determine what the empirical formula is. So let's look at an example. So here's an example problem where we would be given the percent composition and we're asked to find the empirical formula. So you're going to want to pause the video and copy this down. And to work this problem out, here's what I would do. I would look for the different percentages, okay? And I'm going to start with labeling which elements I have, okay? And then I'm going to look back at the percentages, and the first step says to change the percent to grams. So I'm going to copy this down, but I'm not going to write 40.05%. I'm going to write down 40.05 grams. I do the same thing for oxygen. It's 59.95 grams, okay? And then why can we use grams? Why does it magically go from percent to grams? Well, I want you to think about water. Water is the chemical formula H2O. And based on that, the same amount of hydrogen is in like a cup of water as you have hydrogen percent-wise in a swimming pool of water, okay? So you have 2 hydrogens for every 1 oxygen. That's always going to be a certain percentage. So it doesn't matter how much of the sample you have, the percent will always be the same. Therefore, if we have 40% of 100 grams, that would be 40 grams of something. So if we have 40.05% of sulfur, that's going to equal 40.05 grams if we're dealing with a 100 gram sample. All right, so that's the grams. This is the grams of oxygen. Second step, we convert the grams to moles for each substance. So we take sulfur and we are going to we're going to do a conversion. The 1 mole goes on top, but the molar mass of sulfur on the periodic table is 32.06. And we divide by that. Now we need to go to 3 decimal places. Okay, so 40.05 divided by its molar mass is going to give us, to 3 decimal places, 1.249 moles. And then we do the same thing for oxygen, but this time we'll divide by oxygen's molar mass. So we set up our conversion, moles on top, the molar mass goes on the bottom, and this gives us 3.747 moles. Okay, and that's step 2. So moving on to step 3 in the process, step 3 is to divide by the least number of moles. Well, between these 2 numbers, the smallest one is 1.249. So we're going to divide both of these by 1.249. That gives us a 1 in the numerator, or up on top for sulfur. And then this bottom number, when we divide this, we get exactly 3 in the calculator. So you would write a 3. Now, if these were not whole numbers, we would need to proceed to step 4. But in this case, conveniently, it is. So that means our empirical formula equals S with a subscript of a 1 that we don't write in, O3. Okay? All right, and again, these 2 numbers right here, they become the subscript numbers. All right, so let's look at another example. Okay, next example gives us a percentage of nitrogen and oxygen. So we're going to label this nitrogen, oxygen. Nitrogen is 36.84%, but that's our grams, and oxygen is 63.16 grams. So that's our first step. Step 2 is to convert the grams to moles. So we do that by setting up the conversion with the molar mass, so 1 mole over 14.01 grams. And then for oxygen, that's going to be dividing by 16 grams. Okay, so we're going to write this out to 3 decimal places. The reason why is because when we get into figuring out what our subscripts are, that is going to be less likely that we're going to make an error if we have 3 decimal places. So nitrogen is 2.629, and then oxygen is 3.948. So which one of these two numbers is the smallest? We have to divide by the smallest as our third step. It's not always the one on top, but in this case, here again, it is that top number. Anything divided by itself is going to be 1. And then this bottom number is not going to work out to a perfect whole number. This bottom number is 1.502. So because this can't round, actually you didn't know that yet, so unless it is a tenth away from being a whole number, we can't round that and consider it a whole number. So this is 1.5. If it was 1.9, we can make this a 2. If it was 1.1, we can just round it down to 1. But in this case, we can't do that. So I could make this really complicated and give you a whole nother set of rules, or I'm just going to tell you that you basically use the process of trial and error to see what this needs to multiply by to become a whole number. So let's try to multiply it times 2. Now if this doesn't work, we'll back up and we'll try to multiply times 3. Multiplying this times 2 gives us 3.004, okay, which becomes a 3. Because that first decimal place, the 10th spot, is making this within a tenth from being a whole number. So these two have to stay in proportion. Since we multiplied this oxygen number by 2, we have to do the same thing with the top. And that makes our empirical formula equal to N2O3. Okay? And that's how we do it. I'm going to do one more example just to make sure that you guys have this down pretty solid. Okay, so here's the last example. Last example given here. Sometimes you have more than 2 elements in a formula, but for these examples, just to make it kind of short and sweet, these only have 2 different elements. So we have aluminum and we have sulfur. Aluminum, we have 35.98%. That becomes our grams. Sulfur, 64.02. Again, that's our grams. So what do we do as our second step? We're going to convert the aluminum to moles. Need to go to 3 decimal places. That gives us 1.333 moles for aluminum. For sulfur, we're going to divide by its molar mass. So that gives us 1.997. Third step, divide by the smallest. Notice that when I do my third step, I make my division look a little different than this division. That way I can kind of tell them apart. This one's just a horizontal line. This one's a diagonal line. So this is obviously our smallest number. Again, it's not always the top number, but it keeps working out that way, doesn't it? The bottom one, we're going to divide by 1.333. That is going to give us 1.498. Now, this can't be rounded to a whole number, so we have to use the process of trial and error, multiply to see if we can get a whole number. Let's try multiplying times 2. That's going to give us 3.006, something like that. And that does work out to be a whole number, so we do the same thing here. And our subscripts for aluminum is a 2, sulfur is a 3. That's our empirical formula, okay? And again, We may sometimes have to multiply the subscript times 3 or even 4 to get a whole number. It just worked out in this case where, again, we only had to multiply times 2. And that's it.